In this video, we are going to be looking at using nodal analysis to find the nodal voltages V1, V2, V3, and also the current in each of the arms of this particular circuit. Now, if you look at the diagram clearly, you discover that there are no currents, so you can assume the direction of current around the circuit. Now, I can say the current here is I1, okay, I can call that I1. Can say the current here is I2, is pointing outward, so I2. We can have the current here to be I3. Okay, we can have the current here to be I4. We can have the current here to be I5. And we can have the current here to be I6. Okay, so the next is to develop each of the current to represent the current in terms of the nodal voltages. Okay, remember that current is voltage all over resistor. Now, if we look at node 1, let's consider node 1 first of all. Node 1. Now, what you notice is that according to Kirchhoff's current law, the amount of current entering a node is equal to the amount of current leaving that node or that junction. So we can say that I1 is equal to I2 plus I3. But I want us to observe something. I1, now the current I1 is not passing through any resistor, okay? So we leave it as I1. We can't represent it in terms of voltage. Now, but I2 is passing from V1 to V3, okay? So that means, and the resistor, passing through a resistor of 1 ohm, so this will be V1 minus V2 all over 1, okay? Which is the resistor. Now, plus I3. I3 is the current going from V1 to V2, so we can represent that as V1 minus V2. Sorry, this should be V3 from V1 to V3. That's for I2. So V1 minus V2 divided by 1. Okay, so such that if we solve that, we are going to get I1 is equal to V1, 2V1 minus V2 minus V3. Okay, I would like you to write that somewhere. Your I1 is equal to 2V1 minus V2 minus V3. Now, we continue on that node. Let's erase this and let's consider node 2. So if you look at node 2 clearly, and according to Kirchhoff's current law, you see that the current entering the node is I3, but the current leaving the node is I4 and I5. So we can say that I3 is equal to I4 plus I5, okay? Now, I3 is the current from V1 to V2. So we are going to say V1 minus V2 all over 1, which is the resistor, equal to the I4 is passing through 2 ohms. So just from V to the base voltage, okay, which we can represent as V2 divided by 2, okay. Now plus I5. I5 does not pass through any resistor, so we leave it as I5, okay. So if we make I5 the subject of the formula, we are going to see that I5 is going to be equal to V1 minus 3V2 over 2. Okay, so you can write that somewhere. That's our second equation, that I5 equal to V1 minus 3V2 all over 2. Now, we are going to continue with that. We go over to node 3. Now, when you look at node 3, you discover that the current entering node 3 is I2 and I5. But the current leaving node 3 is I6. So we can say that I2 plus I5 is equal to I6. Now, representing it in terms of voltage, your I2 there would be V1 minus V3 all over 1. The resistor there is 1. I5 is not passing through any resistor, so we can't represent it in terms of voltage. We leave it like that. Okay, equal to your I6. Now, your I6 is V3 over V2, passing through a resistor of 2 ohms, and from V3 to the reference node. So that is going to be V3 now divided by 2. Now, if I am to make I5 the subject of the formula, we are going to see that I5 here making I5 the subject of formula, I5 is going to be equal to minus V1 minus, plus 3V3 over 2, making I5 the subject of formula. So you can write it down somewhere. I5 is equal to minus V1, then plus 3V3 over 2. Now, if we check the two values we have for I5, we are going to discover here, let's see, we are going to discover that I5, we can equate them. So we clean this up and we equate. We can, since I5 is equal to V1 minus 3V2 over 2, and the same I5 is equal to minus V1 plus 3V3 over 2. So it means that V1 minus 3V2 over 2 is equal to minus V1, plus 3V3 over 2. 3 over 2. Okay, that's a very good one. Then making V1 the subject of the formula. Let's clean this up for space. Making V1 the subject of formula, we are going to get that 2V1, is equal to 3V2 over 2 plus 3V3 over 2. And then if we multiply through by 2, we are going to get 4V1 is equal to 3V2 plus 3V3. Okay? Now, but you notice here in the diagram that V1 is equal to 12 volts. Since that's the only voltage in this arm and there is no resistor, so your V1 is exactly 12 volts. So we have 12 times 4 is going to give us 28. So 28 is equal to 3V2 plus 3V3, which when we divide through, 48 not 28, which when we divide through by 3, we're going to get 16 equal to V2 plus V3. So you write that somewhere, that V2 plus V3 equal to 16. Okay, that's very good. Now, when you look at the diagram again, we are going to see, we can erase all this time, but you're going to see that V2, between V2 and V3, we're going to see, according to Kirchhoff's voltage law, as you're going from V2 to V3, you're going to see that V2 plus 6 minus V3 is equal to 0. Okay, so we are going to get that V2 minus V3 is equal to minus 6. That's the second equation. We can write that down somewhere. V2 minus V3 is equal to minus 6. Okay, so let's bring out all our equations together. First of all, we have that V2 plus V3 is equal to 16, and we have V2 minus V3 is equal to minus 6. Okay, if we start by adding both sides using elimination method, we are going to get 2V2 to be equal to 10. Okay, so that means that V2 equal to 5. Okay, we can write that somewhere, that our V2 is equal to 5. Now, if we substitute V2 in equation 1, in the first equation here, we are going to get V2 plus, we are going to get 5 plus V3, equal to 16. So that means that V3 now is equal to 11. So here, from what we see here, we can say that our V2 is equal to 5 and our V3 is equal to 11. And we've seen that V1 is equal to 12. Okay, so at this point, we can also find the current. Remember, we wrote down the relationship between the current, and we can go there. Let's see if we can do that quickly. Now, your I1 is the current from V1 to V3. Okay, sorry, your I1 is the one in the arm. Remember, initially we started by saying that I1 is equal to 2V1 minus V3 minus V2. Okay, so we had this. So if we substitute the values, we are going to get 2 times our V1 from what we got is 12. Now minus V3, our V3 is 11. Minus V2, our V2 is 5. Okay, so that means we're going to get 24 minus 16, which is equal to 8 amperes. So our first current I1 is equal to 8 amperes. Now let's see for I2. Let's calculate for I2. Now our I2 is the current from V1 to V3, okay, which we say is V1 minus V3 divided by 2. So that will give us 12 minus our V3 is 11 divided by 2. That is going to give us 0.5 amperes. So we can say that our I2 is 0.5 amperes. Now our I3 is the current from V1 to V2, okay. So we can say V1, our I3 is equal to V1 minus V2 divided by 1. So that is now going to give us our V1 is 12, our V2 is 5, now divided by 1, and that is giving us 7 amperes. Okay, so we have there 7 amperes. So our I3 is equal to 7 amperes. Now it leads us to the I4. Our I4 is, remember we had that I4 is equal to V2 all over 2, okay, and while our V2 is 5 and our 2 and over 2 is going to give us 2.5 amperes. So our I4 is equal to 2.5 amperes. Now for our I5 is the current between V2 and V3, flowing between V2 and V3. We can use our equation there. We said that I5, one of them is that V1 minus 3V2 all over 2. Our V1 is 12 minus 3 times V2. Our V2 is 5, then all over 2. So that is going to give us 12 minus 15 over 2, which is 7.5, and that is giving us 4.5. Okay, so we have 4.5 amperes. So that means our I5 is equal to 4.5 amperes. Now let's see our I6. Our I6, remember, is equal to V3 over 2. Okay, so our V3 we just got now is 11. Now divided by 2, that is giving us 5.5 amperes. Okay, I want to thank you for listening through. Please don't forget to subscribe to our YouTube channel down there. If you have any question, you can send to the box. If you have any contribution, it will be well appreciated. Thank you very much.